let's go. Now, a new one, new and improved. Again, we make marks on the side of the paper, but this time we make marks that we fold onto each other. So one here, one there, and then we fold like this. First, let's start with the left side, halfway point. You guys know, I made all these algorithms, and now we go down, down, up, down, up, down. And I realized, why do I always make it so that I have to fold between 2 points? That's kind of hard to do, right? So down, down. But it's way easier, and coincidentally also more accurate, to just fold 2 points on the side and then fold them on each other. Okay. So down, down, up, down. And another up. And another down. It's really hard to see, sorry. There we go. I'm going to try to make this one very prominent. There. It's in the middle of the others, but I'm just going to mark it. There it is. And on the right side, we go down, up, up. So, down, up, down, wait a minute, this one, right? God damn it. This one. Up, up. Okay, so 1 and 2. There. And now all we have to do is fold these 2 points on each other. Try to be quite accurate with that. All right. Perfect. Not perfect, but well. This now should be way more accurate than last time, or well, my other attempts. Now, my usual, just lift this up, fold it inside like this, make sure this forms a nice point. Open these doors. With that we can already tell if we've been accurate, and it looks pretty good. Off by like 1 degree here. But let's be real, I haven't tried very hard on this one. All right. Opposite way around. The long part of the diagonal should be the bottom left here where our mark is. And now, let's check. And let's actually do it the easy way. I'm just gonna, let's fold this one so I have a line. I'm making sure that I'm following the diagonal here, that I'm going towards these 2 points that I can't see right now. Okay, let's just use this side. Now I can see. There. And now I can just fold this up, zigzag, so like this, up there, on there, and check, does it line up? Well, I have to help out a little bit, but it lines up really well. And here we have our line now, where we need to cut the paper. So that's the Pentagon, the new and improved one. It's actually way more accurate, and I'm going to show you why now with the mathematics. Now first, how did I, my God, figure out where these two marks have to go, that we have to fold onto each other? Well, first, let's complete this pentagon. One is here, one is there. And we had already figured out that this line here is at a 9-degree angle. So what I want to do is, I want this line here, right? So this is the first line we folded by folding this point onto that point. And now the question is, okay, this line, where does it mirror this one? And well, it mirrors it 9 degrees off of this one. So let's just put our line here. Well, it should meet there, but whatever. 9-degree angle. And now I just need to figure out where this is, and we already knew that from previous videos, right? So if I say this is the side length, like this length of one side of our pentagon, then this, well, that's the side length divided by the square root of 2. And compared to the entire length of the paper, well, you can figure that out if we just know, like from last video as well. These are 27 degrees. This is again a side length. So this means that this length here is the side length times cosine of 27 degrees. So now we just put these into one term. We now know that this length here, measured as a part of the side of the paper, is okay, this divided by this plus this, right? Because this is the same as this. So and let's do this smarter. Instead of saying 1 over the square root of 2, I'm just going to pull that down. So it's 1 over square root of 2 times 1 plus cosine 27 degrees. Now, isn't that nice? And from here, I just want to know, what is this angle? Well, it's 45 degrees minus 9 degrees. And that's easy enough, right? That's 36. So how do I get this one with the tangent, right? So we replace this 1 to get that mark by 10, 36 degrees. And there we go. That's the first one. And now the second one, that's, well, I would have said a little bit harder, but it's actually not that hard. We just have to figure out the line perpendicular to the first crease we made that meets here. And there, of course. So it goes like from here, somewhere like through here, not exactly through the middle. Or does it go exactly through the middle? Maybe, whatever. It goes this way. And for this line, well, what's the angle? Well, this one we already know that this is 72 degrees to the diagonal. And we also know, also from last video, that this is 27, so this must be, well, if this is 27, then this is 90 degrees minus 27, which is 63 degrees. So this one, since it's perpendicular, also must have 27 degrees in here. So we just add to this, let's just extend this over here, the distance of 1 times the side length plus the tangent of 27 degrees. So it's just this plus tangent of 27 degrees. There. Now if you want the numbers, I wrote them down somewhere over here. The first one is 32.15%. Oops, whatever. Which is about, let me check that out, a quarter plus 16th plus, oh yeah, that's the longer one, right? Plus, oops, 128th, which is exactly 32, so really close, 0.03125%. So it's only off by like, yeah, is that 1.5? So a bit over 1% actually. And the other one, that works out to be 83.1%, right, exactly. And the approximation I went for here, my God, so that is about, where did I write that down? Oh yeah, 1/2 plus a quarter plus a 16th plus a 60 quarter. I'm just still gonna keep calling it that. And that works out to be 82.8125%. And that, I mean, that's pretty close in my book. And not only is it closer, it's also much easier to just fold 2 points onto each other. So here we go. That's it for today. Thank you for your patience.